So in gathering quantitative data, we need to pay attention to what are called significant figures in those measurements. Anytime you make a measurement, there are going to be certain digits that are known for certain. Or there are going to be specific digits that are known for certain. These are digits that anyone making the measurement with the same instrument would agree upon. Then there will be one digit that is uncertain. Individual readers may estimate the value of that digit differently. So for instance, if we look at the ruler here, the digits that everyone should agree upon would be the 4.7 part of this. And the digit that is unsure of, if we estimate in between the 4.7 and the 4.8, some people might look at that and say, oh, it's 4.72. And so that 2 is our uncertain digit. That's the one we're guessing at. Others might look at it and estimate it to be 4.73. And so that would be okay. And put units on our answer here, centimeters. Okay. So these would be referred to as significant figures. The 4, the 7, and the 2 would be significant figures in the value of this measurement. If we look at the graduated cylinder on the right, we have each one of the lines there represent 1 milliliter. So if I were looking at this, I would say that this is probably going to be 30, my estimate would be 36 points. And now this is where I'd be a little unsure. Is it 36.5, 36.4? So I might look at it and say it was 36.4 milliliters. Again, that 0.4 part being the uncertain digit. And so that would be okay. If someone else were to read it as 36.5 milliliters, that would be fine. And just, so we're aware, remember we read from the bottom of the meniscus, that curved surface of the liquid inside the graduated cylinder. This part of the significant figures isn't too hard to comprehend. What gets a little complicated is when we have other types of measurements. If I look at the lines here up against the ruler, the black line, we should have 3.5, and then the digit that I'm guessing at is probably around 3 or 4. So the 3 is the digit that I'm guessing at. Now if I do the same thing for the red line I look at and say, oh, well that's pretty easy. That's 4.5 centimeters. Okay. Here's the thing. You might say that's 4.5 exactly. It's right on the 4.5 line. Since we're using the same instrument, the same ruler, we should have the same precision in our measurement. Over here, the digit that we're implied that we're guessing at is that 3, or the hundredths of a centimeter. So we have to have the same degree of precision in our other reading of the red line. So if we think it's 4.5 and it's right on the line, we need to put a 0 there, indicating that that is the digit that we're guessing at. Because the reality is that maybe it's a fraction over that or a fraction under that, so 4.9 or 4.49 or 4.51, but that's still the digit that we're guessing at. So we need to have the same implied precision if we're using the same instrument. And again, these zeros become a little bit complicated, which we'll see in just a moment. So in the 3.53, we have 3 significant figures. In the 4.50, we would also have 3 significant figures. Here I'm going to quickly step through the rules for significant figures. You'll have a handout with all of these on them, so you don't need to copy these down verbatim now. But the first thing is pretty straightforward. All non-zero digits are significant, which means that where we're going to have some complications is with zeros. Zeros between significant digits are significant. Final zeros to the right of the decimal place are significant. And finally, numbers less than 1 Zeros that are directly to the right or left of the decimal place are not significant. All right, so just to give you some examples of these, all non-zero digits are significant. So if you have a measurement like 12.3 grams, those are all non-zero digits, so they would all be considered significant digits. Zeros that are between significant digits are significant. So if I were to do a 1 and then say 2 zeros and then a 5, and let's say these are milliliters, so 1,005 milliliters. Here, obviously, the 5 and the 1 are significant because of rule number 1. Because they're between two significant digits, those zeros would also be significant. Final zeros to the right of the decimal place are significant. So if I were to take the 12.3 and add a 0 on there to the grams, now that 0 is the final 0 to the right of the decimal place, so that would also be significant. The idea of significant digits is they are meaningful digits in the measurement that you're looking at. So obviously, if you measure the mass as 12.3, your uncertain digit would be the 3. So you're estimating to 1/10 of a gram. If your balance tells you 12.30, the balance now is indicating that the 0 is the uncertain digit, not the 3. And so you have more precision. So you need to convey that in the number that you write down as the value. And then finally, numbers that are less than 1, zeros directly to the right or left of the decimal place are not significant. So in numbers perhaps like 0.0025 kilograms, for instance, the zeros here are just placeholder values. They're there because we can't write down 0.25. We have to have the zeros there in order to represent the value of the number. So those are not going to be significant digits. So the only digits that we have here that would be significant are the 2 and the 5. So there would be 2 significant figures in this value. We'll get more practice with this stuff in class, but it's good for you to start thinking about, when you take measurements, there's always digits that you know for sure, 1 digit that you're guessing at, and when you write down the number, you need to understand what the precision and implied uncertainty of that value is.